In this lesson, we want to look at the squeeze theory, aka the sandwich theory. What is this theory really saying? Let us use the sandwich for reference. So let us say we classify this part of the bread as, let us say this is G of X. And then the lower part of the bread here, let us say we classify this as H of X. And then between that, we have another function that we squeeze between, and we call this the f of x, right? So here it is that we have three layers, but the one in the blue, which is the f function, was actually squeezed between the other two, right? So this is why it's called the sandwich theory, because if I evaluate these functions. So for example, let us say we take the limit. Let us say we take the limit of the g of x as x tends towards, say, a, right? And we found out that this is c. And then we went below and we took the limits of the h function, right? And we're going to take it as x tends towards the same a. So I want us to pay attention. We took it as it went towards a here. We're taking it as it goes towards a there as well. And when we took it, we realized that we got c again. Remember, we already got c for a different function. That's the one on top. And then we take this one at the bottom. We still get the same thing. The squeeze theory is suggesting that because these two functions, right, are squeezing down on the f function, we can now conclude that the limit of the f function as that same x goes towards the same a will also be c. That's what the squeeze theory is saying. So the conclusion that we're going to be drawing will be based on the fact that h of x, the function, is less than or equal to the f of x function, which is less than or equal to the g of x function. We're saying if we take the limit of this and this at the same point, and we get the same result, we can draw a conclusion that the one in the middle, which is the f function, will have the same limit as you would tend towards that same number that we evaluate. And that is the basis on which the squeeze theory is based on. I want to evaluate the limit of f of x as x tends towards 1 using the squeeze theorem. So given that 5 is less than or equal to f of x, which is less than or equal to x squared plus 6s minus 2. All right, so let us see how we could work this out. Remember, based on the idea of our squeeze theory, we need to evaluate the functions that are to the right and to the left of the main idea. So this is the main idea that we want to draw a conclusion about, right? However, 5 is here. There's no x there, so we're going to keep that. So I'm going to evaluate this to see what I have, right? Because there's no x here for me to substitute, so I can't do anything there. So that's a constant there, so we're going to keep that there. So let us substitute 1 over here. So I'm going to take, so basically what I'm saying is I'm going to take the limit of x squared plus 6x minus 2 as x goes towards 1. So in this case, I'm going to substitute, so I'll have 1 squared plus 6 times 1 minus 2. So 1 squared is 1 plus 6, then minus 2. So that's going to give me 7 minus 2, and this gives me 5. So on this side, I got 5. So basically, let me rewrite this. What I really have is that 5 is less than or equal to f of x, which is less than or equal to, when we evaluate it, we got 5. So because the values I have on both ends, as you could see, is the same number, then because the numbers are the same, we can conclude for the f function that the limit of f of x, right, as x tends towards 1, this is equal to 5. And this is based on the squeeze theory. We can now conclude that. Let's take a look at another problem. All right, let's take a look at this problem here. So it says let G and H be function defined by G of X is equal to X squared plus X minus 1, and H of X is equal to minus X squared minus 4X minus 2. If F is a function that satisfies G of X, which is less than or equal to F of X, which is less than or equal to H of X for all X, what is the limit of F of X as X goes towards -1? All right, so basically, what we're going to do here is to set up our idea like this. So we have F of X is less than or equal to the H of X function, and it is also greater than or equal to the G of X function. So we're going to set up those functions to the right and to the left of F of X. So let us set up the one to the left. So this one is X squared plus X minus 1. And then this is less than or equal to our F function here, which is less than or equal to the G function, which is minus X squared minus 4X minus 2. We are looking at these when we want to take the limit as X goes towards -1. So basically, we're going to isolate these two functions here, and we're going to work them out. And then we're going to come back to compare. So let's take a look. So firstly, I'm looking at the limit of X squared plus X minus 1 as X tends towards -1. So in doing so, what we have here is -1 squared plus -1 minus 1. Whenever you square anything, it is positive. So we have +1, and this becomes -2. So we have a -1 here. So this led me to get -1 finally. I'm going to evaluate here. So basically, I want to take the limit of -x squared minus 4x minus 2. And I'm taking this as x tends towards -1. So in doing so, negative is there. Then I'm going to have my -1 here, minus, and then in here I have my -1, then negative. So let's put this together. Whenever I square anything, it's negative, it's positive, and then there's a negative hanging outside. So this is -1. This becomes +4, and then that becomes -2. What am I looking at? I'm basically looking at 4 minus 3, so this is +1. So this is giving me a +1 right there. So let us now take a look at what's going on. All right. So basically, what I'm going to do now is rewrite what we have. So we're looking at having -1, which is less than or equal to F of X, which is less than or equal to 1. Now, because this number is not the same as this number, then the conclusion is that we cannot determine, the limit, right, as X goes towards -1, right, using the squeeze theory. That's all it means. We cannot tell what it is using this theory because since the numbers did not come back to be the same, it simply means that we can't determine it by the squeeze theory. So sometimes you'll get the same number, you can draw the conclusion, but if the numbers are not the same, we are not able to determine what's going on with that.